Alright, so in this video I'm going to show you how to compute the areas between enclosed functions. So to start off, let me go ahead and give you an example. Suppose we have the functions f of x is equal to x squared and g of x is equal to x plus 2. If we wanted to find the area between this function, which is given by this graph over here, then we can actually use calculus to solve this type of problem, but it's the setup that tends to be the most difficult part. So we'll keep in mind first that our y defines the f of x and our y defines the g of x so that we can plot them in the same coordinate plane. And when we plot x squared and we plot x plus 2, we'll see that there are definite parts where they intersect. Our first step is to identify where those points are. And in order to do that, we simply have to set both of our functions x squared and x plus 2 equal to one another. So we have x squared is equal to x plus 2. And if we move the x plus 2 over to the left side of the equation, we have x squared minus x minus 2 is equal to 0. We can further simplify this into x minus 2 times x plus 1 and find that our x values are equal to x plus 2 or x is equal to negative 1. What this means is that we've actually now found the values in which the two functions intersect each other, or in other words, where the x values are equal to one another. Our next step is to set up an integral to find the area between the curves. Now this can be a pretty confusing part of the problem, so I'm going to go ahead and spend some time on it, just explaining the reasoning behind why it is that we set up the integral the way that we do. So first, consider the function f of x is equal to x squared. I've plotted a miniature graph here just to give you a general idea of the curve and what exactly it is we're looking at. So if we take the integral of x squared and we take the integral from negative 1 to negative 2, essentially the area under the curve that we're going to be solving for is everything that is highlighted in orange. Now if we look at the function g of x is equal to x plus 2, we can go ahead and plot it on this miniature graph again, and if we take the integral from negative 1 to 2, the area under the curve that we're looking for is this shaded area in orange. Or in other words, since we're trying to find the area that's between those two curves and our ranges go from negative 1 to 2 in both cases, we know that we're going to have to subtract the larger function, or the top function, by the bottom function over here. And the reason being is if we take off, if we were to compute this area right here, and then we were to remove the area that we found from f of x is equal to x squared, then what we would be left with is essentially this area right here, which is what we're trying to solve for in our problem. So now we can go ahead and set up our integral. And what that looks like, again, as a general rule, is the area between the 2 points where the functions intersect of the top, the function on top minus the function on the bottom. And as you recall, the function on top is equal to x plus 2, and the function on the bottom, which means just below where this area is equal to x squared, or is given by the function x squared. So we set up the integral just like this. The integral from negative 1 to 2 of x plus 2 minus x squared dx. Our final step to solve this problem is to make use of the fundamental theorem of calculus so that we can solve this definite integral. And basically all that means is we're going to integrate this function as we normally would, and what that means is we're going to split apart this integral so that we have the integral from negative 1 to 2 of x plus the integral from negative 1 to 2 of 2, and this is dx, minus the integral from negative 1 to 2 of x squared dx. And when we have done all of this, we're left with 1/2 times x squared plus 2x minus 1/3 times x cubed. And since we're using the fundamental theorem of calculus, we're going to evaluate the area between the curves between the points negative 1 and 2. And to set up the fundamental theorem of calculus, we have to first arrange the function and plug in our top value here everywhere we see x, which I've highlighted in orange here. And then we have to subtract that from the bottom number of negative 1, and we'll plug that in everywhere we see the x. And after we simplify this equation, using algebra, we'll find that our answer gives us the area between the two curves, and it is going to be equal to 9 halves.